Hi, this is Rajnikant Mishra. Today we are going to find the volumes of largest possible cylinder and cone inscribed in given identical spheres. But before that, let's take a quick view of previous lecture in which we derived the formula for the volume of a sphere. V is equal to 4 by 3 pi r cube. R is the radius of a sphere. Total surface area of a sphere S is equal to 4 pi r square, and the relation between surface areas of a sphere and a cylinder. If you haven't seen that video, the link is given in the description box. Now the volume of largest cylinder inscribed in a sphere. Here r is the radius of the sphere, small r is the base radius of this cylinder, h is the height of cylinder, and O is the center of this sphere. OA is equal to x, so the height AB is equal to 2x. Now apply Pythagoras theorem in triangle OAC. Here A is equal to 90 degree. So hypotenuse OC square is equal to OA square plus AC square. OC is equal to R. Capital R square is equal to OA is equal to x square plus AC square, which is equal to R square. So small r square is equal to capital R square minus x square. The volume of the cylinder V is equal to pi r square h. Now put the value of r square and h in this formula. V is equal to pi r square minus x square and h is equal to 2x. After solving, V is equal to 2 pi r square x minus x cube. Here 2 pi is constant, r is fixed, so for the maximum volume of cylinder, x should be as large as possible. To find the maximum value of x, we have to differentiate both sides with respect to x. dv by dx is equal to 2 pi r square minus 3x square. Now the second order derivative is equal to minus 12 pi x. Because the differentiation of r square is equal to 0 and differentiation of minus 3x square is equal to minus 6x. Here this second order derivative is negative. So for the maximum value of x, put dv by dx is equal to 0. 2 pi r square minus 3x square is equal to 0. R square is equal to 3x square, or x is equal to r by root 3. Why I am doing this will be answered at the end of this video. Now x is equal to r by root 3. So h is equal to 2r by root 3 because h is equal to 2x. And r is equal to under root capital R square minus x square by Pythagoras theorem. Now put the value of x in this expression. It is equal to r square minus r square by 3, which is equal to 2 by 3 r square. So r is equal to under root 2 by 3 into r. Now the volume of the cylinder V is equal to pi r square h. Put the value of r and h in this formula. Pi r square means 2 by 3 r square into h, which is equal to 2r by under root 3 is equal to 2 into 2 is equal to 4, 3 into root 3, 3 root 3 pi r cube. It is the volume of the largest cylinder inscribed in given sphere. Now the volume of the largest cone inscribed in a sphere. Here capital R is the radius of the sphere. Small r is the base radius of this cone. O is the center of a sphere. So OB is equal to OC is equal to capital R. Let OA is equal to x. So the height of cone h is equal to r plus x. Apply Pythagoras theorem in right angle triangle OAC, where A is equal to 90 degree. OC square is equal to OA square plus AC square. So x square plus r square is equal to capital R square. So small r square is equal to capital R square minus x square. And h is equal to r plus x. Now formula for the volume of the cone V is equal to 1 by 3 pi r square h. Now put the value of r square from this formula and value of h from here. V is equal to 1 by 3 pi r square minus x square into r plus x. After solving, b is equal to 1 by 3 pi into r cube plus r square x minus rx square minus x cube. Again 1 by 3 is a constant, r cube, r square and r is fixed. So for the maximum volume, x should be as large as possible. Now differentiate this expression with respect to x. dv by dx is equal to 1 by 3 pi r square minus 2rx minus 3x square. Here the differentiation of r cube is equal to 0, r square x is equal to r square, rx square is equal to minus 2rx and minus x cube is equal to minus 3x square. Now the second order derivative is equal to 1 by 3 pi minus 2r minus 6x. Because differentiation of r square is equal to 0, minus 2rx is equal to 2r and minus 3x square is equal to minus 6x. Here this second order derivative is negative, so for the maximum value of x, put dv by dx is equal to 0. So r square minus 2rx minus 3x square is equal to 0. Now solve it. R square minus 3rx plus rx minus 3x square is equal to 0. R common, r minus 3x plus x common, r minus 3x is equal to 0. R plus x in second bracket r minus 3x is equal to 0. Either r plus x is equal to 0, r is equal to minus x, or r minus 3x is equal to 0. In this case, r is equal to 3x. This is not possible. So, put r is equal to 3x or x is equal to r by 3. Now from Pythagoras theorem in triangle OAC, r square is equal to x square plus r square. Put the value of x, r square by 9 plus r square is equal to capital R square. Small r square is equal to r square minus r square by 9, which is equal to 8 by 9 r square. So r is equal to under root 8 by 9 r, or r is equal to 2 root 2 by 3 into r. Now h is equal to r plus x. R plus r by 3 is equal to 4 by 3 r. Now volume of cone B is equal to 1 by 3 pi r square h. Put value of r and h from here. B is equal to 1 by 3 pi r square is equal to 8 by 9 r square into h 4r by 3. 8 into 4 is equal to 32. 9 into 3 is equal to 81 pi r cube. It is the formula for the largest volume of a cone inscribed in a sphere. Now the ratio of the volume, let it be V1 and it is V2. Pi cancel out, r cube cancel out, 4, 32, 8, 3 and 81, 27. So V1 ratio V2 is equal to 1 by root 3 ratio 8 by 27. We can write 27 as 9 into 3 or 9 into root 3 into root 3. 1 by root 3. Root 3 cancel out. So 1 ratio 8 by 9 root 3. Multiply this ratio by 9 root 3. The final ratio is 9 root 3 ratio 8. V1 ratio V2 is equal to 9 root 3 ratio 8. Now the concept of double derivative. Here is a curve y is equal to fx. Fx be the function of x. If we want to find the slope of this curve at any point, then first we have to find the first derivative of this expression, which is dy by dx. If the slope is positive, it means function is increasing, and in case of negative, the function is decreasing, and at dy by dx is equal to 0, it is parallel to x-axis. Here dy by dx is the slope of the curve. The second derivative of this function, d square y by dx square, is the rate of change of the derivative. This is the critical point of this curve. Here, the slope of the curve changes from positive to negative. If this second derivative of a curve is negative, then this critical point is local maximum. And in case this second derivative is positive, then this critical point is local minimum. Here is your homework. There is a right circular cone given in this figure, in which infinite number of spheres are placed one above the other like this. If this angle is equal to 60 degrees, then find the sum of the volumes of all the infinite spheres. The solution of this question will be discussed in the next video. If you like this video, hit the like button, share it with your friends, and never forget to subscribe and hit the bell icon so that you will never miss any important update.